information is obtained are also provided to the Federal Highway Administration, which collect all the data from all the states. The purpose of PCS is so that we know the present condition of the pavement, so that we can compare with past condition. We can use the information to predict deterioration rate. We know the condition from year to year. We can determine deterioration rate, and also justify annual budgets. Okay, if we know the condition, we know what needs to be fixed, so we can justify the annual budget request. And within the state, there are different districts, and different districts have budget requests, and they need the information in order to make the budget request. Okay, I'm going to share about how flexible payments are evaluated, and then also how rigid payments are evaluated. Flexible payments are evaluated in these three areas. One is the ride quality, rating from 0 to 10, where a 10 would be a perfectly smooth surface. 0 would be the worst you could have. So it's rated in terms of ride number. Ride number is equivalent to the present serviceability index. Some of you may be familiar with present serviceability index, which it has a scale from 0 to 5. Okay, but this ride quality has a scale from 0 to 10. So basically, if you take the ride number, you divide by 2, you have the PSI, the present serviceability index. It also rates its rutting quality. We have a 10, it means there's no rut at all. 0 would be the worst you can have. And also crack rating. Okay, 10 would be a perfect condition with no cracking at all, and 0 would be the worst possible condition. What is considered an acceptable rating for expressway? 6 and over would be considered acceptable. Under 6 would be considered not acceptable for expressways. Okay, the equipment that's used for ride quality evaluation is a high-speed profiler, and this is a picture of a high-speed profiler. This vehicle can be driven over the pavement to be evaluated at whatever speed limit is for that pavement. So you can evaluate very quickly, because all you have to do is just drive this vehicle over the pavement. It has this pavement in the front. There are 3 laser, the 3 lasers mounted in this underneath this front bar, the laser sensor. Okay, and usually it takes only one person to operate. The operator would drive over the road to be evaluated, and this console here could record the starting and the finishing point. Okay. Then basically this front bar here contains the laser sensor. It sends out the signal, and it picks up the reflection, so it can measure the distance between this front bar and the pavement. So it measures this 3 distance, and as it drives over it, you have recording of the longitudinal profile. And the longitudinal profile is then used to compute the right number, using mathematical transformation equation, and it gives a rating similar to the PSI with a scale of 0 to 10. Okay. And it's, the longitudinal profile is also used to compute the IRI, the International Roughness Index. The way it's used to compute the IRI is that it takes this longitudinal profile as experienced by the two wheels, and a software is used to simulate a vehicle going over this longitudinal profile. So as if, even though the vehicle is not really going over it, the software simulates a vehicle going over this profile, and it simulates how a vehicle would, how it would experience the bumpiness that it experienced, and it measures the amount of jerk in terms of distance that it moves up and down. Okay, it's in terms of meter per kilometer or inch per mile, and and it simulates a vehicle driving over that surface at 80 kilometers per hour. Okay, this is a plot showing the relationship between IRI and the present serviceability index. Okay, so the longitudinal profile is used to calculate the right number, which is related to serviceability index. It's also used to generate the IRI, but there's some relationship. I must point out that this relationship is not unique. What I'm showing here is just a relationship for this set of data. For a different set of data, the relationship may be slightly different, okay? But it's roughly, would give us roughly this type of relationship. So if we have a present serviceability of 3, we would roughly get an RI of about 180 inch per mile. Okay, so the longitudinal profile is measured by the laser sensor. It's used to determine the right number, and then also the IRI. Okay, this plot shows the meaning of the IRI. Okay. For newly constructed pavement, the IRI should be in this range. Okay, about from about 100 to 250 inch per mile, or in terms of the metric unit, about 1.5 to about 3.5 meter per kilometer. And if we have the IRI, would be, if the roughness increase, we will have a higher IRI. Okay. Well, so this high-speed profiler is used to obtain those the longitudinal profile, which are then used to get the right number and the IRI. So the equipment needs to be calibrated. I want to talk about the calibration briefly here. Okay, it's very important. The equipments are calibrated for pressure, the accelerometer on the high-speed profiler. This bar here, the front bar, needs to be calibrated so that basically the laser that's mounted on this front bar measures the distance from the bar to the pavement surface, and so that equipment needs to be properly calibrated. Okay, would calibrate it without a block, and then with the block. So the thickness of the block is known. So you have a reading without the block and a reading with the block, so we can calibrate the distance correctly. The distance measurement, the instrument is distant. It's also need to be calibrated. This DMI give us the distance traveled by the vehicle. It gives the starting point and the finishing point. So this equipment needs to be properly calibrated. Okay. And how do we calibrate it? Every month would use the vehicle and drive over at least 3 pavement sections with the known, with the known longitudinal profile. And so currently they actually do 4 calibrations per month. Okay, and then the smoothness was checked with this class 1 profiler, which is a chip, the dipstick. Okay, so this device is used to measure the profile of a reference section, and so we try the high-speed profiler over it. We can check it with the actual measure profile of that test section. And every year, it would, the raters rater would be would verify that the various sections were the correct data were obtained from the various reference sections. Okay, so that covers the evaluation for ride quality and roughness. Next, we want to cover how rutting defects are rated. Okay, what is rutting? Okay, rutting is the permanent deformation of the pavement surface along the wheel path, and this usually happens only on flexible pavement. Okay. So typically, to measure rut, you would put a horizontal bar across the pavement, and you find the deepest distance with respect to this bar, and that's the rut depth. Okay. Well, this could be done quickly using this high-speed profiler. So basically, you need to place the laser profile, the laser sensor needs to be placed basically at a distance where it corresponds to the wheel path. Okay, and the standard vehicle usually would have the wheel-to-wheel spacing corresponding to the typical wheel path. And so we measure this 3 distance and draw a horizontal line across here. And so the distance from this point to this horizontal line would be approximately equal to the rut depth. Sorry, somebody, can you turn it off? Oh, sorry, can you turn it off? Sorry. Somebody gave me sorry about that. Somebody lent me, my former student lent me his cell phone so he can call me whenever he needs to. Yeah, you can say that, well, this is really not an accurate method of measuring rut depth, but it gives us an approximate measurement. Okay, how do we translate rut measurement to rut rating? This is the way to translate. You have the rut depth, okay, and for each rut depth, there's a corresponding deduct point. Okay, so for example, if the rut depth measure is ½ an inch, it would have a deduct point of 4. You subtract the 4 from a 10, so you have a rut rating of 6. Okay. So as I pointed out earlier, for interstate highways, 6 or above is considered acceptable. If anything over 6 is not acceptable. Okay. To be accurate, to get accurate measurement, it needs to be done manually. Okay, so basically you place a horizontal bar across and measure it. Okay, with the high-speed profiler, you can get a quick estimate of the rut depth. If it's done manually, we use the same deduct point system. So if you have a rut depth of ½ an inch, we still have a 4.4 deduct points, and so the rutting rating would still be 6. Okay, next we want to cover how cracking is evaluated. Well, to evaluate cracking, to recognize the type of cracks, this is a type 1B crack. It's defined as such with the crack width less than 3.18 mm. Then we have class 2. If it's greater than 3.18 mm but less than 6.35 mm, it will be classified as class 2. And class 3 are cracks that exceeds ¼ inch or 6.35 mm. And also raveling, patchings are also considered. Okay, the way it's done is that they separate into 2 parts. The cracking along the wheel path, that's CW, and cracking outside of the wheel path, the CO. So do a rating along the wheel path and rating along the outside the wheel path. The rater identifies the type of crack and the frequency of the crack, and there's deduct points assigned to the combination of crack and the frequency of crack. Okay, and the same point systems are used for outside the wheel path. Okay, so you evaluate the area along the wheel path and outside the wheel path, and their deduct points, and so you have deduct points, and the deduct points are then added together. Okay. So we start with 10, and we have deduct points that's associated with cracking along the wheel path, that's CW. And there's deduct points associated with cracking along the outside of the wheel path. And so these 2 deduct points are added together, and the sum is subtracted from 10. And that's how the cracking is rated. Okay. And so that kind of summarized how flexible pavements are evaluated for their condition. What about rigid pavement? Well, in rigid pavement, usually we don't have rutting problem. So it's evaluated based on right rating. And right rating will get right number and IRI. And so this portion is similar to that for the flexible pavement. So the high-speed profiler would be driven over the pavement, and the same procedure is used to get the right number and the IRI. So I want to just cover the defect rating. The rater needs to identify the different types of distress, such as surface deterioration, spalling. Spalling is cracking near the joint, patching, transverse cracking, longitudinal cracking, corner cracking, shatter slab, and faulting. That's faulting is the difference in elevation at the joint. If you have faulting when you drive over the joint, you feel a bump. Okay, and that's a form of distress. Okay, this is equipment to measure faulting. Pumping, the signs of erosion of the material underneath the slab. Usually, it's you can see streaks of fine materials extending out from the